Hello and welcome to my channel. In this video, we will learn different types of examples from indices topic. To start with, you should have knowledge about the laws of indices. I encourage you to watch my video on laws of indices before starting this video. You will find the link in the description box of this video. So let's start with the first question. Evaluate 0.2 raised to the power of negative 2. So for the first one, what we can do is, we can write 0.2 to a negative power. We can change it to a positive power by using one of the laws of indices. So I am going to take 0.2 at the bottom. So when I inverse it or reciprocate it, the negative power becomes a positive power. So what we are going to do now is, we are going to use a calculator and we are going to check how much is 1 divided by 0.2 square. So let's check. It is 25. So the answer for this first one is 25. So here we have used a basic rule of indices, that is a to the power of negative n. If the power is negative, what we have to do is, we have to just reciprocate the same number and the negative power becomes a positive power. This is the law of indices we have used in this question. Now let us look at the second question. So this is the first one. Let us look at the second one. The question says you have to simplify 16 a to the power of 12 raised to the power of 3 over 4. Now here we have used the rule of indices as, if we are writing something as a times b raised to the power of n, then we have to distribute this power to a as well as to b. So I am just giving you an idea of the rules we have used. So this is the rule we have used for this question. Now let us see how we are going to implement it. Here, a times b to the power of n. 16 times a to the power of 12. So it is nothing but 16 times a to the power of 12 raised to the power of 3 over 4. So as we distributed the power here, we have to distribute this power to 16 as well as a to the power of 12. So it becomes 16 raised to the power of 3 over 4 times a raised to 12 raised to the power of 3 over 4. So we have simplified this by a step. Now the most important thing we have to observe is the denominator of this power, 4. Now think about a number who is raised to a power of 4 gives you 16. So here we can think about this 2 to the power of 4, because 2 to the power of 4 gives you 16. So let us raise it this way and it becomes 3 over 4 times, here it becomes 12 multiplied by 3 by 4. Now for this one, again we are going to use a law of indices, that is, if a is raised to the power of n is raised to a power of n, then we simply write it as a raised to the power of n times n. So this is the law we have used. Now what happens over here? Using this law, we can write it as 2 to the power of 4 times b over 4. The powers get multiplied times, here the power is already multiplied. So 12 times 3 over 4. Now fraction multiplication, we know that 4 times 3 over 4. We can cancel off this 4 1 times, 4 1 times. Here also we can use the same thing. 12 times 3 over 4, 4 1 times, 4 3 times. This 12. So simplifying further, we can write it as 2. Over here only 3 has remained. So 1 times 3 is 3 into a to the power of 3 times 3 is 9. So 2 cubed is nothing but 2 times 3 times 2, which is 8, and a to the power of 9, and we get this 6 because it cannot be further simplified. So this is the way we have simplified 16a to the power of 12 raised to the power of 3 of 4. So this is the most simplified answer. Let us look into the second question. Find the value of each of the following. 5 over 3 is raised to the power of negative 2. Again, if you remember, we had a power of negative 2 in the previous one. So we had just reciprocated it. So 0.2 over 1, if we are taking this way, had become 1 over 0.2. So basically we have to reciprocate whatever number we have to get a positive power. Now in this case, if you see, we have got it as 5 over 3 to the power of negative 2. So we simply reciprocate it. So it becomes 3 over 5 and the negative power changes to positive power. Now again we are going to use the law of indices over here. So if we are getting something as a over b to the power of n, then we are going to distribute the power to the number at the top and at the bottom separately. So it becomes a to the power of n over b to the power of. Using this law, we are going to solve the above example. So here it becomes 3 to the power of 2 over 5 to the power of 2. So 3 square is 9 and 5 square is 25. As simple as that. So this is the answer for the first one. For the second one, now it says 81 raised to the power of 3 over 4. We have to look at the denominator of the fraction of the power here. Now think which number raised to the power of 4 gives you 81. The number is 3. 3 raised to the power of 4 gives you 81. So let us check for ourselves. It is confirming. So 3 raised to the power of 4 gives you 81. So here in place of 81, I write here 3 to the power of 4 is again raised to the power of 3 over 4. Here the powers now will get multiplied using the law of indices. So it becomes 4 times 3 over 4. Again using the fractional multiplication, we can cancel 4 1 times, 4 1 times. So here we are left with 3 to the power of 1 times 3, which is 3 again. So 3 cubed or 3 to the power of 3 is nothing but 3 times 3 times 3, which is 27. So this is the most simplified answer for 81 raised to the power of 3 over 4. Let us look into another example. We can see they have asked us to simplify the given expression. Here what we are going to do is we have to distribute the power in the numerator to each of the terms. So in the numerator we can write it as 4 raised to the power of 3 times x to the power of 5 is again raised to the power of 3 times y to the power of 3. So as you can see, this power is being distributed to each term inside the bracket. This whole thing is divided by 2xy squared. So we write it as 2 into x into y squared. And this denominator is written as 8 times x to the power of 10 times y to the power of 4. So I have just opened up the brackets. There is no distribution of power because there is no power outside the bracket. So only the distribution happens if the power is outside the given brackets. Now let us simplify the numerator. 4 cubed is 64 times x to the power of, as we know the powers will get multiplied. So 5 times 3 is 15 times 1 to the power of 3. This whole thing is divided by, I am going to multiply the numbers first. 2 times 8. Since there is multiplication between all the terms, take the number multiplication first. So 2 times 8 is 16. Then here x is raised to the power of 1. So if x is not given as any power, take it as a 1. Now what happens here is x to the power of 1 times x to the power of 10. They both are like terms. So here using the property of our law of indices, we know that if a is raised to n times a is raised to n, then we can just add up the powers, n plus n. So the bases, a is called as a base. So if bases are same, just add the powers. So here if we are adding the powers, we get it as 1 plus 10, which is 11 times. Now y squared times y to the power of 4. Using the same law, we have to just add up the powers. 2 times, so 2 plus 4 is 6. Now let us further simplify this. We can write 64 over 16. So 16 1 times, 16 4 times is 64. Now we can write it as 4 times. Now if there is division, if the bases are same and there is a division in between them, we are going to use the other law of indices. That is, if a to the power of m is divided by a to the power of m, we are going to subtract the powers minus n. So here we can write x to the power of 15 minus 11. Same goes for the y. So we write it as y 8 minus 6. So finally we get it as 4 into x to the power of 15 minus 11 is 4 times y to the power of negative 3. So you can keep it this way, or if you want to have all the positive powers, then you can just write it as 4x to the power of 4. Now y to the power of negative 3. So we can just write it as 1 over y to the power of 3, making it a positive power. So this is the way we solve this question. Let us look at the next question. The first question says to evaluate or to solve 9 to the power of negative half. Now you have to look at the denominator of the given power, 2. So now think which number raised to the power of 2 gives you 9. It is very obviously 3, because when we square 3, we get 9. So in case of 9, we will write 3 to the power of 2 and then write the outer power the same way. Now, using the laws of indices, we know that we have to just multiply the powers. So 2 times negative half. So when we are multiplying the fractions, 2 times negative half, this 2 1 times, 2 1 times. It gets cancelled. So you have 3 to the power of 1 times negative 1 is negative 1. Now again remember, the law of indices says if there is a negative power, you can change it to a positive power by just reciprocating the number. So we get the answer as 1 over 3 raised to 1 or just 1 over 3. This is the way to solve this example. Now let us look at the second example. Simplify. So let me write down the question. Simplify 4x to the power of 4 raised to 3. As you can see, there are brackets. It means we have to distribute this 3 to 4 as well as x to the power of 4. So we can simply write it as 4 is raised to the power of 3 times x is raised to 4 is again raised to the power of 3 and y square stays the same. 4 divided by 2 times x to the power of 3 times y to the power of 5. So let us solve this further. We get it as 4 to the power of 3 is 64 times x. Now powers get multiplied using the laws of indices. So 4 times 3 is 12 times y square. 14 divided by 2 into x to the power of 2 into 5 to the power of 5. Now just make sure that you are keeping the letters arranged one below the other. So below the x, keep a x. Below the y, keep a y. Now we can just divide 64 and 2, which goes in the same table, to 1 times and to 32 times. So we have 32 over here. And since there is a division, we use the laws of indices and the powers get subtracted. Same goes with y, 2 minus 5. Now this ends as 32 times x to the power of 12 minus 2 is 10 times y to the power of negative 3, which can further be written as 32 x to the power of 10 over y to the power of 3, y cubed. As you can see, the negative power has become a positive power. So this is the solution and most simplest way of solving this example. The next question is asking us to express the following in the form of 2 raised to some power p. So whatever answer we get, it should be in this form. So let us start with the first one. 2 to the power of 5 divided by 2 to the power of 7 is raised to a power of 3. I can simply write this given thing as 2 to the power of 5 over 2 to the power of 7 raised to a power of 3. As you know, the bases are same, 2 and 2, and there is a division. We have to subtract the powers using the laws of indices. Is raised to a power of 3. So we get it as 2. 5 minus 7 is negative 2 raised to 3. Again, we are going to use the law of indices and we are going to multiply the powers. So it becomes Negative 2 times 3 is negative 6. So if you wish to keep it this way, now this question we have to get in the form of 2 to the power of p, as it is given in the previous question. To do this, the way we have to approach this is, let us write 5 the way it is, times, we can split the powers and write it as 4 raised to the power of 2 times 1 over 3. Because 2 times 1 over 3 gives you 2 over 3 again. So we can split the power in this way. Plus 3 times, we can keep the second term the way it is. Now here, next what I can do is, I can take this term together. So I get it as 5 times 4 to the power of 2 is 16 raised to the power of 1 over 3 plus 3 times 16 to the power of 1 over 3. As you can see, 16 to the power of 1 over 3 and 16 to the power of 1 over 3 are present in both the terms. So I can just factorize and take it common out and write it as 16 to the power of 1 over 3, and the terms remaining are 5 plus 3 inside the bracket. Further simplifying this, I can write it as 16 to the power of 1 over 3 times, this is multiplication, 5 plus 3 gives us 8. Now the thing is, they want us to write the answer in terms of 2 to the power of something. We know that 16 is a power of 2. That is 2 to the power of 4 gives us 16. So in place of 16, I will write 2 to the power of 4 raised to 1 over 3. And I also know that 8 is a power of 3. That is 2 cubed gives us 8. So here what we get is the powers get multiplied, and we can simply write it as 2 to the power of 4 over 3 times 2 to the power of 3. And using the law of indices, that is a to the power of m times a to the power of n, as we know, we have to add the powers. So we have to write here as 2 raised to the power of 4 over 3 plus 3. So that gives us 2 to the power of 4 plus 9 is 13 over 3. So let me write it plus 9, 15 over. So we have got the answer in terms of 3. So here in this case, p is equal to 13 over 3. You have to be very careful in solving these kind of questions and check for all possibilities. So this is one way to get the answer for these kind of questions. These are another set of questions which could be asked in the indices topic. These questions are pretty easy to solve. So let us see how we are going to solve them. Solve the equations 3 to the power of n is equal to 1. Now, solve the equations means you have to get the value of n, the value of p, the value of t, all the variables. Now, for the first one, let us see. Solve 3 raised to n is equal to 1. Now, think about a value of n when 3 is raised to that value, you get a value of 1. So if you take n equal to 1, so let us substitute here, we get 3 to the power of 1, which is 3, which is not a correct value. if we take n equal to 2, we get 3 to the power of 2 equal to 9, which is not equal to 1, which is not the correct answer. So what if we get n equal to 0? So if we put the value of n as 0, we get 3 to the power of 0 is equal to 1. So this is the way. So n is the value of n is 0. To confirm it, you can always check in the calculator. 3 is raised to a power of 0. That gives us 1. Now let us look at the second question. T to the power of negative 3 equal to 64. Get the negative power as a positive power first. So we have to just flip it and write it as 1 over t cubed equals 64. Now you can just multiply the t cubed over here using cross multiplication. So you get 1 equals 64 times t cubed. Or you can simply write t cubed is equal to 1 over 64, making t cubed as a subject. From here, what we need to do is we write t equals cube. When we send on the other side of equal to sign, it becomes a cube root. It is again a law of indices. So 1 over 64. Let us check what is the cube root of 1 over 64. So cube root of 1 divided by 64 gives us 1 over 4. So the value of t is 1 over 4. So we got the value of n, we got the value of t. Let us look at the value of what we will get. As we know, we have to distribute the power to each term within the bracket. We write it as 8 to the power of 1 over 3 times t to the power of 6 raised to the power of 1 over 3 is equal to 8. Again, we look at the denominator. Think of a number who is raised to a power of 3 gives you 8. That is 2. When we cube 2, we get 8. So in place of 8, we write 2 cubed and raised to the power of 1 over 3 times t. Here the powers get multiplied. 6 times 1 over 3 equal to 8. Now here as well the powers are getting multiplied. So 2 to the power of 3 times 1 over 3 t to the power of 6 times 1 over 3 equal to 8. So let's simplify this. 3 1 times, 3 1 times, 3 1 times, 3 2 times is 6. So we get 2 to the power of 1 is 1, 2 to the power of 1 is 2, and here we get t, the power is squared equals 8. So we have t squared equals 8 over 2. We get t squared equal to 2 1 times, 2 4 times, so 4. Now using the laws of indices again, when the square goes on the other side, it becomes a square root of 4. So a square root of 4 is 2. So we get the value of t as 2. Or we can also write it as plus or minus of square root 2 and plus or minus of 2. So whenever we are taking the square root, it is usually present in two signs, plus or minus. We can take either plus or minus. So P has two values. This is a way to solve these kind of questions. Express each of the following in the form 5 to the power of k. This is same as the previous one where they had asked us to write the answer in terms of p to the power of k. So let us see how to solve this. We should express 25 to the power of 4 as 5 to the power of k. So let us see that 25 to the power of 4. 25 can be written as 5 squared because 5 squared is 25. So we can write here 5 squared raised to the power of 4, and here simply we have to just multiply the powers 2 times 4 using the laws of indices. So we get it as 5 to the power of 8. So the first one we have got in terms of powers of 5. Let us look at the second one. 1 over 4th root of 5. In the laws of indices, we can write anything, the nth root, we usually mention it as nth root of a, could be written as a fractional power. So nth root becomes 1 over n. So if we have a square root of a, we can write it as a to the power of half. If we have a cube root of a, we can simply write it as a to the power of 1 over 3. And if we have a fourth root, we simply write it as a to the power of 1 over 4. So we can see that this is the fourth root. So we can simply write it as 1 over 5 to the power of 1 over 4. And if we want to get it in the form of 5 to the power of k, we just take it as 5. Now remember we are reciprocating it. 1 over 5 becomes 5 over 1. So the power becomes negative because we are changing it from a positive power. So it is vice versa. Negative power becomes positive, positive power becomes negative. So the answer is 5 to the power of negative 1 over 4. So we got the answer in the form 5 raised to k. Now let us look at the last question. We should get 5 times root 5 the whole cube in the form of 5 to the power of k. So I will write the terms inside the bracket as 5 times, this is square root of 5. So square root can be written as a fractional power. So I will write 5 to the power of half. Now let us raise it to a whole 3, the outside power. Now as we know, the power outside gets distributed to each of the terms inside. So simply we can write it as 5 to the power of 3 times 5, half and 3 gets multiplied, giving 3 over 2. Now as we know from the laws of indices, if a raised to n times a raised to n, then we simply add the powers. That is what we are going to do here. We are simply going to write it as 5 raised to 3 plus 3 over 2. That gives us 5 raised to 9 over 2, which is of the form 5 to the power of 8. if they had asked us to find in the formula. So this is the way we can solve it. Now let us look at the next question. Express each of the following in the form 7 to the power of k. Again, we should get these questions in the form of k to the power 7 to the power of k. So let us look at the first one. It is the fourth root of 7. So we can simply write it as 7 to the power of 1 over 4. This is explained in the previous questions because we used the law of indices in this. So we have expressed this as 7 to the power of 1 over 4. Now let us look at the second question. 1 over 7 square root 7. Now this can be written as 1 over 7 and square root can be written as 7 to the power of half. Now if we see here 7 is raised to the power of 1 and here 7 is raised to the power of half. So we can simply write it as, using laws of indices, 7 to the power of 1 plus half. That will give us 1 over 7. 1 plus half is 3 over 2. Since they want us to write the answer as 7 to the power of k, again using laws of indices, we will take the 7 to the numerator and so the power sign changes. The plus becomes minus. So now this resembles 7 to the power of k form. This is how we solve the second question. Now let us look at the third question. 7 to the power of 4 times 49 to the power of 10. So let me write it over here. 7 to the power of 4 times 49 to the power of 10. Now they want us to write this in the form 7 to the power of k. So here we don't have to do anything because 7 to the power of 4 is already in this form. Now 49. 49 can be written as 7 to the power of 2 because 7 squared is 49. Now again we will raise it to the power of 10. Now using the laws of indices, we can simplify the second term as 7 to the power of 2 times 10, which gives us 20. Now again, we can just use the laws of indices and write here as 7 to the power of 4 plus 20. So it becomes 7 to the power of 24. This gives the answer in the form 7 to the power of k. This is how we solve these kind of questions. Now let us look at another kind of question which is quite popular in the examinations. Solve the equation 2 to the power of 1 minus x equals 4 to the power of x. So let me write it down again. 2 to the power of 1 minus x equals, now this 4 I can write it as a power of 2. Looking at this, I will understand that 4 can be written as a power of 2. So I will write 4 as 2 squared and then write this power the same way. Here it is. Now it simplifies as 2 to the power of 1 minus x equals 2. These two powers will multiply. So 2x. Now if the bases are same, here is 2, here is 2, we can directly equate the powers. So we can write the powers as 1 minus x is equal to 2x. Now solving this further, we can take the like terms on one side. So I will take the negative x on this side. So it becomes 1 equals 2x plus x. So 1 equals 2x plus x gives us 3x. Therefore, x is equal to 1 over 3. So we have solved the value of x. This is how we solve these kind of questions. Try to get the bases in the same format as I have got here. And then keep solving by taking the powers. These are another set of questions over here. So another kind or another type of example from indices topic. Given that 2x squared minus x to the power of 3 over 2 over square root of x can be written in the form 2x to the power of 3 minus x to the power of 3. Write down the value of p and value of q. Now to solve this, what we can do is, we can write the numerator 3 over 2 over a square root of x. We know that we can also write it as 1 over 2. Now after doing this step, I am going to write the numerator and split it as 2x squared over x to the power of half minus x raised to 3 over 2 over x to the power of half. Now using the laws of indices, I know that these two are having the same bases, x and x, and there is a division. So I can write 2 minus half. Here the powers get subtracted. Minus x 3 over 2 minus half. Because again the bases are same, x and x, and there is a division. Therefore the powers will get subtracted. Now further solving this, we get as 2x, 2 minus 1 over 2 gives us 3 over 2 minus x, 3 over 2 minus 1 over 2 gives us 2 over 2. So the final step is going to be 2x to the power of 3 over 2 minus x to the power of 1, because 2 over 2 is 1. Now let us compare the answer we have got to the form they have asked us to write. It is 2x to the power of 3 minus x to the power of 2. So comparing the powers here, 3 is equal to 3 over 2 and q is equal to 1. So we have got the values of the powers asked. We have got the value of p and q. This is the last question from this topic I have covered. Given that 3 to the power of x equals 9 to the power of y minus 1, show that x is equal to 2y minus 2. A very simple example, as you have already understood, I hope, what we are supposed to do. 3 to the power of x equals, now I have to think if 9 I can write in terms of 3. So we know that 3 squared gives us 9. So in place of 9, I will write 3 squared raised to the power of y minus 1. So here we can further write it as 3 to the power of x equals 3. These two powers get multiplied. So we write it as 2 times y minus 1. Now since the bases have become same, we can directly equate the powers. So it becomes x equals 2 times y minus 1. So we can further distribute this bracket and write it as 2y, and 2 times minus 1 is minus 2. So we have got the answer and we have shown that x is equal to 2y minus 2. So this is how you solve these examples. Since they are asked for 2 marks, you can write 4 steps to solve the example.